Okay, let's work on finding this limit as x approaches 36, where we have a square root involved. So I noticed that really stands out to me as I'm looking at this problem. The very first way you always want to start all of these limits where you have your x approaching a specific value is go ahead and just try evaluating the function by plugging in that value that you're approaching in for each one of your x's and see what happens. Now in our case, I think we're going to end up with the indeterminate case, basically just saying, hey, we got 0 over 0. You want to continue moving forward with this, but it's not going to be that easy. If you get to anything else besides just 0 over 0, it will be, you'll be done. All right, but in our case, because we got to 0 over 0, let's kind of move back to the beginning, start all over. How you want to approach this is we have a square root involved. It's only in the numerator. If we happen to have a square root in our denominator, we would approach this slightly differently. But how I want to approach this is I'm going to go ahead and multiply numerator and denominator by what we refer to as the conjugate. All right, and what that means is you're going to multiply numerator and denominator by the same two terms, the square root of x and the 6, as what are in the numerator, except for you're going to switch the sign. And by switch the sign, I mean this was a subtraction sign, so its conjugate is going to be an addition sign. So doing the same thing between numerator and denominator, let's take our time and multiply this out. So we have the limit as x approaches 36. You want to bring that along. Take your time with it. For the denominator, I'm just going to bring along that x minus 36, and I'm not going to multiply it by, not multiply out by square root of x plus 6. All right, and the reason why I'm not going to take the time to multiply that out, we already learned that by plugging in the 36, we got a 0 in our denominator. So that tells us that we want this x minus 36 to go away. All right, so if I leave it as a factor, I'm hoping we can get rid of it pretty easily. All right, so next, multiplying out the numerator, let's think to ourselves basically first, outer, inner, last. Sometimes we use the acronym FOIL or the distributive property to help us out. All right, so the first terms we'd have square root of x times square root of x, which makes just x to the first power. All right, for the outer, we have square root of x times positive 6, which is plus 6 square root of x. For the inner, we have negative 6 times square root of x, which is minus 6 square root of x. And for the last, we have negative 6 times positive 6, which will be negative 36. All right, well, at this point, let's go ahead and think to ourselves, can we simplify our numerator at all? Now, I notice that we are both adding a square root of 36 and subtracting a square root of 36. Adding a square root of x times 6 and subtracting a square root of x times 6. That makes these like radicals. So we can go ahead and combine those together and say that makes 0 square root of x's. All right, a little bit more simplifying. Let's continue on. We have the limit as x approaches 36. And what's left in the numerator looks to be just x minus 36. Denominator, x minus 36, and the square root of x plus 6, both as factors. But now we've gotten to the point where in our numerator, we can go ahead and say, well, we have an x minus 36 multiplied by the entire numerator here, and an x minus 36 multiplied by the entire denominator. We can reduce that down to lowest terms, and we're allowed to do that because we're doing a limit. What remains in our denominator is going to be that square root of x plus 6, but we also have to keep a 1 up in our numerator kind of as a placeholder. All right, at this point, we can kind of wrap it up by, again, substituting that 36 back in where the x is, and simplifying that the square root of 36 is going to be 6 plus 6 in our denominator, or 1/12 as our overall result. All right, hope this helps out as you're working on taking limits as x approaches specific values. Remember, always fill in for the variable initially, and if you get to 0 over 0, keep going. There are quite a few different techniques to learn to kind of master all the different ways to get through these. So I hope this helps out. Good luck.